Lesson 2, Electric Flux. Section 2.2. Electric flux density. There is a point charge with positive q coulombs. Let's suppose a closed surface CS, that encloses the point charge. By definition, the total number of electric flux lines psi through CS, is positive q coulombs. Regardless of the shape of the surface, psi is equal to q coulombs. This is an electric flux line. Along the flux line, electric flux density D at point P is defined as the number of electric flux line per square meter. D is a vector, and its direction is the same as that of electric field intensity E. The unit is coulomb per square meter. If a differential surface element ds is placed at point P, how many electric flux lines cross ds? An is a unit vector normal to ds. Theta is the angle between an and d. Then the differential flux d psi, which is the number of electric flux lines crossing ds, is given by this equation. And the equation is written using the inner product of the vectors d and an. It can be further rewritten using the vector surface element ds, which has a magnitude of ds and a direction of an. Suppose there is a point charge of positive q coulombs at the origin of the Cartesian coordinate system. And let's assume that this point charge is enclosed by a spherical surface CS with a radius of r meters. All the electric flux lines cross the spherical closed surface. By definition, the total number of electric flux lines crossing the surface is psi, and it is equal to q coulombs. The electric flux density D at the spherical surface is radial, and its magnitude is uniform at every point on the surface. The electric flux density at the spherical surface is the number of electric flux lines per square meter. Thus, D is expressed by this equation. Q is divided by 4 pi r squared. 4 pi r squared is the surface area of sphere with radius r. An is a unit vector normal to the spherical surface. Its direction is the same as that of D. A vector differential surface ds is chosen so that ds equals dsan. Thus, the differential flux d psi is equal to the inner product of d and ds. The electric flux psi is reobtained by the integration of d ds over surface cs. The result is q. Exercise 2.2. This is your homework. Pause the video, and answer the problem. Show that the electric flux density D equals ρ over 2 pi r times an. The author of this material is Takeshi FURUHASHI, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.